I'm Anil Kumar. Let me thank all our viewers and especially those who are sharing previous test papers. Now, we have received previous 5 years of test papers from Trinity College, and from those test papers, I have selected 10 questions which are all based on logarithms. By sharing with you the solution of these 10 questions, I hope you'll get a lot of knowledge and information about how to solve questions based on logarithms. This will be a very useful exercise for students taking calculus in coming time. So let's begin with the questions first. We begin with very simple questions. Question number 1, write log to the base 2, 1024 equals to 10 in index form. Evaluate log to the base 2 of 32. Evaluate log to the base 3 of 64. Divide by log to the base 3 of 0.5. Now this is a slightly difficult question. Then we have two very similar questions here. Let x equals to log to the base n 5 and y equals to log to the base n of 4. We need to write expression x minus y over 2 as a single logarithm, and the second one, express log to the base 5 over 4 in terms of x and y. Question number 6. Express y in terms of x given log to the base 2 of x plus y plus 2 equals to log to the base 2 of x minus 2y. Now this is also slightly tricky, so I hope you find it interesting. Question number 7. Determine k if 2 log to the base 4 of x equals minus log to the base 4 of 3 plus 1 is log to the base 4 of k based on logarithmic rules. Question 8. Determine the exact solution of 3 times 4 to the power of x minus 1 equals to 18. That is also a bit difficult. Question number 9. Determine the exact solution of 4 e to the power of 2x minus 81 minus 5 e to the power of 2x. It is similar to previous one, and the last one here is solve for x. Log to the base 2 of x plus log to the base 4 of x plus log to the base of 16x is 21 over 4. So that is the toughest question in this group. So I hope you find these questions interesting and useful. Now let's take their solutions one by one. The very first question is to write in index form. That means we have to write in exponential form, right? Okay, so what we really do is we take the base, this is the base, whether you have logarithmic function or exponential function. So on the right side, we get 2 to the power of 10. So base is 2, it remains as the base, and that should be equal to 1024, correct? Question number 2 is to evaluate log to the base 2 of 32. So we could write log to the base 2 of 32 as equal to log to the base 2 of 32 is 2 to the power of 5, correct? So using the power rule, we get this as 5 log to the base 2 of 2, and that is equal to 5, correct? So this is equal to 5. Question number 3. Evaluate log to the base 3 of 64 and log to the base 3 of 0.5. Now here we are going to use change of base formula. So if we are given log to the base a of x, we can change the base to anything like b and write it as log to the base b of x over log to the base b of a, right? So what we will do here is we'll change the base to 2. Since 64 is also power of 2, we could write 64 as 2 to the power of 6, and 0.5, which is half, is equal to 2 to the power of minus 1. So these are the substitutions which we can do and then evaluate the given expression. So we are given log to the base 3 of 64. Let's write like this, over 1 over log to the base 3 of 0.5, correct? Now, changing the base means we'll change the base to log to the base 2 of 64 divided by log to the base 2 of 3. Here, it's in the denominator. We'll write this as log to the base 2 of 0.5, and divided by means comes in the numerator, log to the base 2 of 3. Now clearly, log to the base 2 of 3 cancels. Do you see that part? So if you're given like this, you can easily change the base even without doing all that. So what we get here is log to the base 2 of 64 divided by log to the base 2 of 0.5 is half, right? Now as we are saying, 64 is 2 to the power of 6. So we could write this as log to the base 2 of 2 to the power of 6. And this is log to the base 2 of 2 to the power of minus 1. So that gives you 6 over minus 1 or equal to minus 6. So this is equal to minus 6. Clear? So it's very important to see how we change the base and got the solution. Question number 4 is, let x be equal to log to the base n of 5 and y equals to log to the base n of 4. Write x minus 2y as single log. So x minus y by 2. X is, so let's rewrite, x minus y by 2. X is log to the base n of 5. So we'll write this as log to the base n of 5 minus y is log to the base n of 4 divided by 2, right? So that basically means log to the base n of 5 minus log to the base n of, this is half, right? That means square root of 4, right? Which is 2. So we'll write this as log to the base n of 5 minus log to the base n of square root of 4 is 2. And then minus means we'll divide it, right? So we have log to the base n of 5 divided by 2, right? So that is how we are going to simplify. You could also write this as log to the base n of 2.5. Is that clear? So that is how we could actually solve. Question number 5. Let x be log to the base n of 5 and y be log to the base n of 4. Express log to the base 5 of 4 in terms of x and y. So log to the base 5 of 4, we could change the base to n, and we could write this as log to the base n of 4 divided by log to the base n of 5, right? And log to the base n of 4 is y. And log to the base n of 5 is x. So this is equal to y over x. Is that okay? So we could write our answer as log to the base 5 of 4 is equals to y over x. Question number 6. Express y in terms of x given log to the base 2 of x plus y plus 2 is equal to log to the base 2 of x minus 2y. So let's rewrite the question. Log to the base 2 of x plus y plus 2 equals to log to the base 2 of x minus 2y. Correct? Now, number 2 can be written as log, let's rewrite. So we could write this as log to the base 2 of x plus y plus, this could be written as 2 times log to the base 2 of 2, right? So that means log to the base 2 of 2 is 1, so we get 2. So that is the trick here. And here we get log to the base 2 of x minus 2y. Now here we can apply the property, when you have plus, they get multiplied, right? So we have, let me go one more step and then we'll multiply, correct? Which is basically log to the base 2 of 2 square, which is 4, right? So we could write this as log to the base 2 of x plus y, and when it's product we just multiply. So it's multiplied by 2 square, which is 4 here, correct? Equals to log to the base 2 of x minus 2y. So now, because they have the same base, we could equate x plus y times 4 to x minus 2y. Now we need to write y in terms of x, right? So we have to isolate y. So let's expand. We get 4x plus 4y equals to x minus 2y, correct? So let's take it to the right side. All the y terms will come on the left side. Let's write 4y plus 2y is equal to x minus 4x, correct? So we get 6y equals to minus 3x, or y equals to minus 3 over 6x, which is minus half x. So that is how y will be related. So y is equals to minus half x is our answer. Perfect. So that is how it should be solved. Now let's look into question number 7. I'd like you to pause the video, answer this question, and then look into my suggestions. 7. Determine k if 2 log to the base 4 of x minus log to the base 4 of 3 plus 1 equals to log to the base 4 of k. So we are given 2 log base 4x minus log 4 3 plus 1 equals to log to the base 4 of k. So base is 4. So we'll write 1 as base of 4. So we get log to the base 4 of 6 minus log to the base 4 of 3 plus 1 can be written as log 4 of 4, correct? Apply the property. Here let's go one more step. We can say log 4 of 6 squared minus log 4 of 3 plus log 4 of 4 equals to log 4 of k, right? So we get here log to the base 4 of, this is 36, right? We have to multiply by 4 and divide by 3. That should be equal to log 4 of k. So now we get 36 times 4 over 3 equals to k, correct? So from here we can say k is, that goes 12 times, correct? So k is 12 times 4, which is 48. So we have k equals to 48 as our answer. So that is how it should be solved. Question number 8. Determine the exact solution of 3 times 4 to the power x minus 1 minus 18. Now here the base is 4, okay? So what we get here is 3 times 4 to the power of x minus 1 equals to 18. We can divide by 3, so we get 4 to the power of x minus 1 equals to divide by 3. So we get 4 to the power of x minus 1 equals to 18 divided by 3, which is 6. Now to solve this, we have to take logarithms on both the sides. So we can take log of 4 to the power of x minus 1 equals to log of 6. So that means x minus 1 times log of 4, the base is 10, equals to log of 6, right? So now we can actually isolate x. So from here we get x minus 1 equals to log of 6 divided by log of 4, or x is equals to log of 6 divided by log of 4 plus 1, which you could also write this as log of 6 plus log of 4 over log of 4, correct? So that is the value of x which you get, and that is the exact value. You can use calculator to find the approximate value. Question number 9 is similar to previous one. Determine exact value of 4 e to the power of 2x equals to 81 minus 5 e to the power of 2x. So let's rewrite 4 e to the power of 2x equals to 81 minus 5 e to the power of 2x. Let's bring e terms together. We get 4 e to the power of 2x plus 5 e to the power of 2x equals to 81. So that is 9 e to the power of 2x equals to 81, or e to the power of 2x is 81 divided by 9. So we get e to the power of 2x equals to 9, right? Now at this stage, what we could do is we can take natural log on both the sides, correct? So we'll take natural log on both sides. So whenever we are working with e, it is good to take natural log. So we have ln e to the power of 2x equals to ln 9. Now that gives us, we could do two things here before taking natural log, because this is e to the power of 2x. So what we get here is it is just 2x, right? So e and ln are, so we have 2x equals to ln 9, or x is equals to half of ln 9, correct? Or x is equals to half of, 9 square root you could do, but I think that's good enough. So we could write this as our solution, correct? Now, it is important to note at this stage, we could have done square root and we could have got plus minus 3, right? So we could have got plus minus 3. Now remember, whenever you are doing ln x, in that case, x is greater than 0, right? So that is the domain, correct? Therefore, we are not considering negative 3. So let me rewrite this. This answer could also be written as x equals to ln square root of 9, right? And square root of 9 is 3. So we have x equals to ln 3. Now we will not write plus and minus, since we should have a positive x value. So that becomes our final answer. Is that clear to you? So that is important to understand. And now let's take our last question, question number 10. Solve for x, log to the base 2 of x plus log to the base 4 of x plus log to the base 16 of x is equal to 21 over 4. So we need to find what the value of x is. You can always pause the video, answer the question, and then look into my suggestions. Now here we are going to use change of base formula. So if I have log to the base a of x, we can change the base to b. B could be any other relevant base, and write the formula as log to the base of a of x is log to the base b of x divided by log to the base b of a, right? So that is the formula well known to all of you. We are going to use this change of base formula to solve this question. So as you can see, the base are different, right? So we'll change base to 2. So that is the criteria, right? So if I change base to 2, what do I get? So let me rewrite the question. We are given log to the base 2 of x plus log to the base 4 of x plus log to the base 16 of x is equal to 21 over 4, correct? Now first one is okay. Let's keep it as log to the base 2 of x. Now here 4 could be written as log to the base 2 of x divided by log to the base 2 of 4, correct? So we have used this particular formula. Now log 16, we could write log to the base 2 of x divided by log to the base 2 of 16. And on the right side, we have 21 over 4. Now what is log to the base 2 of 4? So let's write this on the right side and then we'll replace. Log to the base 2 of 4, as you know, is log to the base 2 of 2 square, which should be 2. and log to the base 2 of 16 is log to the base 2 of 2 to the power of 4, so that should be 4, correct? So we'll replace these values, and what we get here is log to the base 2 of x plus log to the base 2 of x divided by 2 plus log to the base 2 of x divided by 4 equals to 21 over 4. Now let's multiply everything by 4. So we get 4 log to the base 2 of x plus 2 log to the base 2 of x, correct? So 4 and 2 remains. And here we get log to the base 2 of x equals to 21. Multiplying by 4, get rid of this denominator. So we have 4 plus 2, 6 plus 1, 7. So we can write 7 log to the base 2 of x is 21, right? So this gives you that log to the base 2 of x is 21 over 7 or 3, right? So now writing it in the index form, we can write x as equals to 2 to the power of 3, which is 8, correct? So we have solved for x, which should be 8, right? So our answer is x equals to 8. So that is how we are going to solve this question. I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.